Okay, factorization is the complete opposite process of multiplying out. There are four types of factorization: highest common factor, factorization, the difference of two squares, grouping or common brackets, and finally quadratic trinomials. Now, whenever we factorize an algebraic expression, we always look for a common factor first. Before we look for any other form of factorization, we look for a common factor first. This entire exercise is based on highest common factor factorization. So we'll get to the other forms of factorization in another exercise. So to factorize these expressions, what we are essentially doing when we are dealing with common factors, we're essentially dividing each term by the highest common factor. So you should be very familiar with finding the highest common factor of two or more numbers. We're talking numerical values now, not anything that has to do with variables. So if you're not comfortable finding the highest common factor of two or more numbers, then I suggest it's strongly advisable that you obtain worksheets and work through them before you attempt highest common factor factorization with variables. So when we're looking at an expression like 6m plus 12t, we're looking at each term and we are looking to find the highest common factor we can take from each of those terms, whether the expression is 2 terms, 3 terms, or 25 terms. We're taking a common factor from every single one of the terms in that expression. So what we're essentially doing is dividing each term by the highest common factor. So the highest common factor between 6 and 12 is 6. So we divide each term by 6 and we write that number outside of a set of brackets. Inside of the set of brackets are the terms that remain after that division. So 6m divided by 6 will just give us m, and 12t divided by 6 will give us 2t. Now, an important thing to note is that the number of terms inside the factorized bracket needs to match the number of terms of the original expression. In other words, the original expression 6m plus 12t contains two terms. Inside the factorized brackets, we have still got two terms. And you should always check your work, regardless of what the question is. In any aspect of maths, you should always check your work. So if we multiply 6m back into the brackets, 6 with m gives us 6m, and 6 times 2t gives us 12t. That's how we know that we're factorized correctly. B, 9t plus 3p, the highest common factor between, we're just looking at the coefficients now, 9 and 3, the highest common factor between 9 and 3 is 3. So we divide each term by 3. We take it out as a common factor outside of a set of brackets. Then 9t divided by 3 gives us 3t. So the remainder of that division is the first term of the brackets. And 3p divided by 3 just gives us p. Again, we have two terms inside the brackets. We started off with two terms. We multiply 3 times 3t, we're going to get 9t. And we multiply 3 by p, we get plus 3p. C, 8m plus 12k. The highest common factor between 8 and 12. Now 8 does not go into 12, but 4 goes into 8 and 4 goes into 12. So the highest common factor between 8 and 12 is 4. We take that out as a common factor. 8m divided by 4 leaves us with 2m, and 12k divided by 4 leaves us with 3k. Again, inside the brackets we have two terms. We started off with two terms. 4 times 2m gives us 8m, and 4 times 3k gives us 12k. For r plus 8t, the highest common factor between 4 and 8 is 4. 4 goes into 4 once and into 8 twice. 4r divided by 4 gives us r, and 8t divided by 4 gives us 2t. Again, we have two terms inside the brackets. The original expression contained two terms. 4 times r gives us 4r, and 4 times 2t gives us 8t. The rest of the exercise should be pretty straightforward. I'm just going to skip through to P, which is the first question that has got three terms. It doesn't make a difference how many terms you have. You just need to remember that When finding the highest common factor of an algebraic expression, every single term needs to contain that common factor, that highest common factor. So we have 4a squared plus 6a plus 8. So we're looking at the coefficients first, 4, 6, and 8. The coefficients 4 and 6 and the constant term 8. The highest common factor between 4, 6, and 8. 4 will go into 4 and 4 will go into 8, but 4 does not go into 6. However, 2 goes into 4, 6, and 8. So the highest common factor here would be 2. We have an a. Yes, we have a squared. We have two a's in the first term. We have a single a in the second term, but there are no a's in the third term. The highest common factor must be common to all the terms. Since there isn't an a common to all the terms, we cannot take an a out. So the highest common factor of this expression is 2. 4a squared divided by 2 is 2a squared. 6a divided by 2 is 3a. 8 divided by 2 is 4. We have 3 terms inside the factorized brackets. We started off with 3 terms. 2 times 2a squared gives us 4a squared. 2 times 3a gives us 6a. And 2 times 4 gives us 8. Let's jump ahead to S. 6mt squared minus 3mt plus 9mt squared. Again, we're going to start off with the coefficients, the numerical coefficients, 6, 3, and 9. The highest common factor between 6, 3, and 9 is 3. 3 will go into 6 twice, 3 will go into itself once, and into 9 3 times. We also have an m in the first term, an m in the second term, and m squared in the third term. So we have the highest common factor of m. And then the t's, we've got 2 t's in the first term, 1 t in the second term, and 1 t in the third term. So the most we can take out is a t from each term. Open up our brackets. 6 divided by 3 is 2. We've taken the m out, so that's no longer there. So m divided by m is 1. And t squared divided by t is t. 3 divided by 3 is 1. That minus sign needs to be there. Because the minus divided by plus is a minus. M divided by m is 1. T divided by t is 1. Essentially, we've taken out this entire term. So what we're left with is a negative 1, not 0. Be very, very careful there. 9 divided by 3, there's a plus sign here. 9 divided by 3 is 3. M squared divided by m is m. And t divided by t is 1. We have 3 terms in the factorized bracket. We started off with 3 terms. 3mt times 2t. 3 times 2 is 6. M t times t is mt squared, so we get the first term. 3mt times minus 1 gives us minus 3mt. And 3mt times 3m. 3 times 3 is 9. M times m is m squared. And then t times 1 is t. The last one we'll do is u. So 10 pt squared plus 15 pt plus 5 pt squared. The highest common factor between 10, 15, and 5 is 5. 5 goes into 10 twice, into 15 3 times, into itself once. Looking at the p's, we have a p in the first term, a p in the second term, and 2 p's in the p squared in the third term. So the most we can take out is a common p. We have t squared in the first term, t in the second, and t in the third. So we can take out a t at most. So each term is divided by 5pt. 10 divided by 5 is 2. P divided by p is 1. And t squared divided by t is t. Plus 15 divided by 5 equals 3. P divided by p equals 1. T divided by t equals 1. Plus 5 divided by 5 equals 1. P squared divided by p equals p. And t divided by t equals 1. Again, check. We have 3 terms in the factorized bracket. We have 3 terms as in the original expression. 5 pt times t. 5 times 2 is 10. pt times t is pt squared. 5 pt times 3 gives us 15 pt. And 5 pt times p will give us 5 p squared t. 3 friends have a meal together. They each have a main meal costing $6.75 and a dessert costing $3.25. Carla says that the bill will be 3 times 675 plus 3 times 325. Suni says that she has an easier way to work out the bill as 3 times 675 plus 325. Explain why Carla's and Suni's methods both give the correct answer. Okay, so Carla says we're going to take 3 times 675 and add it to 3 times 325. Suni says we're going to take 3 times 675 plus 325. Okay, well, let's have a look at Carla's method. The main meal is 675, and there are 3 friends, and they each pay the same. So 3 times 675 will cover the main meal. And then they each have a dessert costing 325. So the 3 of them, 325 times 3 is the dessert. And then they add it and they get the total. Suni is saying we can just add the meal of 675 to the dessert of 325 and then multiply by 3. It's exactly the same thing. If we multiply this 3 times 675 using Suni's method, if we just multiply that out 3 times 675 plus then 3 times 325, we are essentially getting this expression here is in fact what Carla's calculation. So it's exactly the same thing. That's why they both give the correct answer. It's just the same thing written in a different way. Explain why Suni's method is better. Well, as far as calculations are concerned, the fact that we're dealing with decimals, here, if we multiply 675 by 3 and then 325 by 3 and then add them, we're going to be dealing with decimals here. If you didn't want to, you're not exactly going to take a calculator, unless you are yourself a walking calculator, you're not going to take a calculator out to dinner and use it, unless you want to use your phone, but you shouldn't. The point is, you don't really want to calculate decimals in your head, right? So the easiest thing to do would be to take the 675, the cost of the meal, add it to the cost of the dessert, which will give you 675 plus 325 gives you 10, and then multiply by 3. So that would give you a total of $30. Far easier to do that, to add the decimals first, get a whole number, then multiply by 3, as opposed to multiplying by each decimal by 3 and then adding it. We can do that. 675 times 3, 75 cents times 3 is $2.25, and 6 times 3 is 18. So we'll have 18 plus $2.25, which is $20.25. Then 3 times $3.25, 3 times 3 is 9, and 25 cents times 3 is 75 cents. That gives us $9.75, and then if we add 20.25 plus $9.75, we are going to get $30. It's far easier to add the decimals first and then multiply by 3. That's why Suni's method is better. So the total bill is $30. I'm going to leave question 3 for you to do as an exercise because it's very similar to question 1. I am, however, going to just start with F, right? To factorize a squared plus b. Now, there are no common factors here, right? A squared is a times a, b is b times 1. Now, there is no common factor other than 1. There is no common factor between a squared and b. Now, in an exam, you're not just going to leave this open, because if you don't write anything down, you'll get 0. If there are no common factors, you'll simply just write out the expression again, right? If you do not write a squared equals a squared plus b, then you will not get any marks. If you leave it open, if you leave it blank, you will, the examiner will think that you have not answered the question and therefore will award 0 marks. So just make sure that if it doesn't factorize, you just write out the expression again. Let's do another example. H 3ab plus 4CD. Let's look at the numerical coefficient first, 3 and 4. There's no common factor. There isn't a common factor between 3 and 4. We have A times B in the first term and C times D in the second term. There also isn't a variable that is common between the two terms. So again, we write out the expression. Again, 3 equals 3AB plus 4CD. If you leave it blank, you'll not get any marks. I'll leave the rest of the exercise. In fact, let's just do D as well. 8PT plus 5AB. There isn't a common factor between 8 and 5. We have P times T in the first term and A times B in the second term. There are no common factors between these two terms. So again, we're just going to write the expression out again. Failing to do so, you will not get any marks. Let's just do one more. 4m squared minus 6mp. There's a common factor of 2 between 4 and 6, so we take that out. We have an m in each term, so we take that out as a common factor. 4m squared divided by 2m will give us 2m minus 6 divided by 2 gives us 3. M divided by m equals 1, and p divided by 1 equals p. We have two terms in the factorized brackets. We started off with two terms. 2m times 2m gives us 4m squared, and 2m times minus 3p gives us minus 6mp. Three students are asked to factorize the expression 12m minus 8. The answers are below: Ahmed, Bernice, and Craig. All the answers are accurately factorized, but only one is the normally accepted answer. Which student gave the correct answer? And explain why the other two students' answers are not acceptable as correct answers. Okay, so let's just forget about the three answers. We are going to factorize as we have been doing, right? 12m minus 8, and then we will then go and answer the question. So the highest common factor between 12 and 8 would be 4. 4 goes into 12 3 times and into 8 twice. So we take out the common factor of 4, and then we're left with 4 times 3m. 12m divided by 4 equals 3m, and minus 8 divided by 4 is minus 2. Now, if we just take this, our answer here, and compare it to the 3 that we've been given, we can clearly see that our answer agrees with Bernice. Right, so that would be the answer to the normally accepted answer. Right, so the correct answer will be Bernice. Now let's see why the other two students are not acceptable as answers. So Ahmed said it was 2 times 6m minus 4. Now, if we multiply out, 2 times 6m is 12m, and 2 times minus 4 is minus 8. So Ahmed did factorize. There's nothing wrong. He factorized correctly, but the problem with this solution is that if you look at this bracket over here, 6m minus 4, still contains a common factor of 2. If you factorize just this expression here, you'd have 2 times 3m minus 2. That means that he did not take out the highest common factor, and that's why his solution would not be regarded as being correct. If we look at Craig's answer, 4m times 3 minus 2 over m. If we multiply m, 4m times 3 is 12m, minus 4 times 2 is 8, and then m divided by m equals 1. So there's nothing wrong. Multiplying back in does give us the expression that we started off with. But his answer is not correct because we do not generally have fractions inside a factorized bracket. And the problem with what Craig did here is the expression 12m minus 8 does not contain a common factor of m amongst the two terms. There's an m present in the first term, but there isn't an m present in the second term. So if the term is not present, if the common factor isn't there, you don't force it to be there. Because if you force it to be there, you will have the situation where you will have a fraction with a variable, and we avoid that. We don't factorize that way. So if the highest common factor is not there, you don't force it to be there. Explain why 5m plus 6p cannot be factorized. Well, the simple answer is there are no common factors between 5m and 6p. There isn't a common factor between 5 and 6. There isn't a number that goes into 5 and goes into 6, and m and p are different variables. So to answer this, again, do not leave the answer blank. You will not be awarded any marks. You must write out equals and write out the expression again. Alvin has correctly factorized the top and bottom of an algebraic fraction and cancelled out the terms to give a final answer of 2x. Unfortunately, some of his work has had coffee spilt on it. We're required to find out what the original fraction was. Okay, so if we just look, the only way we could actually know what work is missing here is if we work backwards. So we've got the final answer of 2x. If we go back to the previous step over here, we have 4x times something divided by 2 times x minus 3. Now, in order to get 2x, we can clearly see that 4x divided by 2 would give us 2x. That means whatever has been erased here must be identical to x minus 3 because he's cancelled out common brackets. So this over here has to be x minus 3. So in other words, we start off with 2x. It equals 4x times something over 2 times x minus 3. What's inside that bracket must be x minus 3 because when he cancels those two brackets, you'll get 4x divided by 2, which is 2x. So this step over here, you just erase that quickly. We have 4x times x minus 3 over 2 times x minus 3. Then to get to the previous step over here, we know that the numerator, 4x, whatever's circled over there, is this over here, and we have 2 times something over there. So the step that precedes this second step here is really just the multiplication of 4x times every term inside the bracket. So the numerator will have 4x squared minus 12x divided by, we bring in the 2 into the brackets, 2 times x and 2 times minus 3. We have 2x minus 6. So this is the original fraction that Alvin started off with, factorized it, and got to this step over here, cancelled the x minus 3 brackets, and had 4x divided by 2, which gave him an answer of 2x. So this is the original expression that Alvin started off with.